Okay, we can go ahead and get started then. So welcome everyone. I'm Jeremy Simon with 3D Universe, and welcome to another episode of 3D Universe Untethered. This is an ongoing series where we sit down with folks in the 3D printing and digital fabrication industry, talk about what they're doing with this cool technology. And today's episode is especially exciting because we get to talk about 3D printed housing, which is just super interesting and super cool. So we've got lots of questions. I am joined today by my colleague, also from 3D Universe, Alina Dragu, who will be co-hosting today. So welcome, Alina.
Hello.
And our guest of today is Sam Ruben, who's the Chief Sustainability Officer and co-founder at Mighty Buildings. And maybe, Sam, you could just give us an introduction, a little background on yourself.
Certainly, and really appreciate the opportunity and excited to be here with you today. So as you mentioned, I'm the Chief Sustainability Officer at Mighty Buildings. Prior to founding the company, I was working as a sustainability consultant and sustainability coach, helping organizations optimize their bottom line and improve operational efficiency by focusing on savings in waste, water, energy, as well as transportation. So looking at things like full building systems, the envelope, the HVAC, lighting, but also things like what's it mean to move a garbage can 10 feet? And how do you model out those potential savings? So what I would work with organizations, everything from large municipalities to small nonprofits to mid-sized businesses, really kind of all over, identifying opportunities and then modeling out the savings, both in terms of the sustainability impact, but also the economic impact, and then helping them make that business case up to their C-suite to really implement those solutions.
Excellent. I want to invite, as always, our audience, those who are attending today, to use the QA panel, as well as the chat function to ask questions or share comments throughout today's discussion. We want to get you involved as much as possible, so please do use that. We'll keep an eye on that throughout today's discussion and bring that in either during or towards the end as time allows. Okay, so let's get into this. I'm really excited. Like I said, this is something that I've been following for a long time. So first, let's just be clear what we're talking about here. Mighty Buildings is 3D printing full-size homes and structures. Is that right, Sam, that we're talking about here?
Sort of. So with the ADUs that we're delivering currently, because it's new technology, we've been moving incrementally. So the units that are on the ground right now, they're a hybrid. So they have a 3D printed curved wall with a traditional steel frame box. We're bringing forward a new generation of those modules next year that also will have a 3D printed back wall and a 3D printed roof. But we have already a prototype where we fully printed the shell, and we're able to do so at full industrial speed in less than 24 hours.
Wow.
So we already have demonstrated the ability to do in a single day what would normally take a 5-person crew an entire week. And on top of that, we have a new panel system that we're bringing to market next year, which has all the walls fully printed, and it's kind of like a Sears kit home for the 21st century. And so the idea there is modules are great and they're amazing, and you can install them and get them moving ready in really short amount of time. But cranes and power lines do not play well. And so with the panel system, what it does is it allows us to deliver the units in shipping containers and then access backyards that might be restricted otherwise. But even more so, it allows us to begin our expansion into the B2B market and working with builders and developers. Because while we started with accessory dwelling units and started with homeowners, that was really more as a beachhead market to really take advantage of the changes in state law that made it easy to permit those, as well as working in a space that's difficult for a lot of bigger builders and developers to do because of the overheads associated with a smaller unit. But our vision has always been to be a tool for industry. And so with this new panel system, we're able to not only do the units we have currently, the first product being the Mighty House, which we have 3 versions ranging from a 864 square foot, 2-bedroom, 1-bath to a 1,440 square foot, 3-bedroom, 2-bath, a single family home. And those were designed with EYRC architects out of Los Angeles, one of the country's leading modern design firms, as well as Burrow Happold Engineering, which is one of the world's top engineering firms. And so that's the first product that we're deploying the system with. But we've already signed an agreement with a developer in Southern California to begin doing some custom floor plans based on the panel system. And we're actually looking forward to deploying what will likely be the largest 3D printed community development in the next year or so.
Nice. That sounds exciting.
It does.
Because that's where we have impact at scale, is by working with the developers and the builders who are building at scale. Because obviously housing affordability, you can do a lot of great work working directly with homeowners. But if you shift from one unit at a time to 10, 20, 30, 100, 1,000, then you start really having impact at scale and really starting to put a dent into the problem.
Absolutely. Well, so then starting maybe just with the basics of a single unit being developed, tell us about how that process works and what sort of a time frame are we talking about start to finish in producing one of these?
Yeah, so one of the things that we're doing with our customers is we offer a full turnkey option. So along with the unit, we also handle the foundation, the utilities, the permitting process, project management, coordinating general contractors, making it as easy as possible for the customer. And so the most variable part of that is the permits. The state's done some great work to really streamline that process, but especially coming out of COVID, with everything going on, there's a lot, there's still some backlogs and everything. But once the permit's in hand, we can go from a blank slate to fully installed in a month.
So you guys are currently just in California, and there are plans to expand outside of California onto the West Coast and then nationwide, correct?
Correct, yeah. So we're already in just conversations with builders across the United States, including like Arizona, Pacific Northwest, but as well as places like Southeast, like Florida, as well as upstate New York, Illinois, and we also have interest from some builders and developers around the world as well. And one of the really cool things about the fact that we're doing fully digital fabrication with 3D printing and robotic finishing cells is that we can set up in a really small footprint. Like where I am right now, even though it looks like beautiful and sunny, this is our unit, one of our units in San Diego, one of our one-bedroom mighty duos will be installed earlier this year. But I'm actually in our facility in Oakland, which is a 79,000 square foot former Pete's Coffee warehouse, of which 50,000 square feet is production. And we're in the process of scaling so that we'll be able to actually deliver 1.2 million square feet of units out of 50,000 square feet of production. And so what that means is that instead of needing hundreds of thousands or millions of square feet in an area far away from the demand, we're actually able to set up in areas of demand where the workforce is. And so our vision is to be deploying these printing hubs, what we call mighty factories, in those areas where we have partners, where we have demand, so that we're minimizing those logistic costs, we're minimizing the carbon costs of that transportation, and that we're also not exporting California construction costs to other states, because that's
great.
That'd be silly. So that's something we're really excited about, is to create this global distributed production network that really serves those markets and also attracts a new generation of workers into the industry, because they want to work with cutting edge technology. Because that's obviously one of the biggest issues facing the industry right now is just the lack of labor.
Yeah.
I was talking to a professor at the University of Denver Burns School, real estate management and construction, and he was saying something like 400,000 construction jobs are open right now, and no one's taking them.
Wow.
And that's everything from skilled GCs and trades all the way to the basic framing. And there's just not enough labor. So what we're trying to do is really help address that, because at the end of the day, it's not our goal to replace labor. Our goal is to leverage cutting edge technology in order to allow the existing labor force to do more. And
sorry, go ahead.
Go ahead.
I was going to ask, because you brought it up, because then you're talking about kind of shifting from the stick-built to this new sort of technology. So how does that fit in? What's the difference between the mighty buildings, homes, and your stick-built homes? So, what are the advantages of these homes other than what you already touched on, which was the fact that they're much faster to build?
Yeah, so speed is a big part of it. Quality, we're delivering type 2 semi-luxury units at a standard price. So we're actually about 40%, the units we're delivering currently are about 40% less than comparable quality units that are made traditionally. Additionally, it's a high level of sustainability. So the production process itself is zero waste. We print exactly what's needed. We have the ability to capture, because the 3D printing is just the first step. So we do the 3D printing, and then it goes into a robotic finishing cell that utilizes industrial robotic arms that are proved out in the automotive industry. And what that does is allows us to do additional automated quality control. We can do a 3D scan of the printed object to make sure it matches with the digital file. Okay. it also creates a digital model that we then use to create the toolpaths for the post-processing. And the post-processing involves the ability to mill the surface using CNC heads that are normally used for soft metals like aluminum or copper. And so what that means is we can leave it with the raw print, which some people really, really like, and actually pay a lot of money to have people do manually on traditional methods, or we can mill it to a really smooth stone finish. Or, and this is where I get excited, because along with the versatility of design that the 3D printing brings in, so the ability to do curves, organic forms, or traditional aesthetics, we have the opportunity with the milling to mimic brickwork, to mimic siding, or to create whole new looks that no one's ever thought of before and really unlock that creativity of architects and of designers. And then what we're working on is a spray attachment as well, which will allow us to do things like stucco, paint, primer, again, further adding to the versatility of design, and also allowing us to fully automate the pouring of the foam insulation into the interior, which is part of our energy efficiency. Nice. Because our material is about 4 times more insulating than concrete. And so with the addition of the foam, we're actually able to easily achieve, and not only achieve, but exceed California's zero net energy standards and begin getting into things like passive house that are really pushing the boundaries of what it means to be an energy efficient home. And so that begins to address the 40% of energy use in the United States that is buildings, and also addressing the affordability question, because affordability isn't just your upfront cost. It's also, what's that cost of ownership look like?
So then what is your, do you have an R rating for the homes, for the walls and the ceilings, floors, all of that?
So a 6-inch panel with the foam insulation has an R value of 21.
Nice. Okay.
Yeah. So and we're actively working on improving that. And with we've got the next generation of the technology is reinforced with continuous fiber. Okay. And what's really cool about that, so if you have a beam of that material and a beam of the reinforced concrete, our reinforced material has about 20 times better tensile strength. And depending whether you're along or across the fibers, either equivalent compressive strength or 2 times better compressive strength, all while being 4 times less in terms of weight and 4 times better in terms of insulation. So that's really exciting, because that's where we then begin to step into low-rise multifamily, which is a huge opportunity in terms of really getting units onto the market, as well as being where a lot of the affordable housing is.
Nice. So,
oh wait, I realize I only partially answered your question. So the sustainability is a huge part of it. We're looking at being able to eliminate 3 to 5 pounds per square foot of waste that normally goes to landfill. So that's like 1 to 2 metric tons of CO2 per unit that we're eliminating, just not existing. Additionally, we're working on end-of-life recyclability, because for us, it's important that we're not just looking cradle to gate, but that we're looking all the way cradle to cradle. And so we already have the ability to grind the material up and then sift it and reuse as filler. But we're looking at more advanced technologies such as pyrolysis that can convert it into clean energy, as well as things like biological degradation using algae or fungi. So we're really looking at some of those new technologies that are coming online to really close that loop. So the sustainability is a huge aspect of what we're doing, and the energy efficiency, as well as the material efficiency and the reduction of waste. Cost, as I mentioned, we're 40% less than comparable strut quality, time, and then just the quality. So it's really unique, and we're able to eliminate a lot of the additional materials. So where we're going with our certification roadmap is the ability to use our material and as everything from the interior finish to the exterior finish, including your fire barrier, your air water barrier, thermal barrier, vapor barrier, and really eliminate those 8 to 12 layers that you would normally have in order to achieve that.
So do you have an idea of what the lifespan of the buildings then would be? Because stick built, we already kind of know, and depending on where you are, you know, in some areas where you have termites and other issues, your lifespan of your building is going to be a lot less than in other areas.
And if you've got XPS, I really hope there's no ants around. So, but no, yeah, and one of the cool things is our material is naturally antimicrobial. So it's resistant to mold, fungus, things like that.
Oh, that's great.
Yeah, additionally, we've done accelerated aging tests out past 70 years with roughly 10% degradation. So as on par or better than most traditional materials. And so we feel confident saying 50 years, but honestly, we're looking at further testing to be able to potentially establish 100 years, because it is essentially a synthetic stone.
Yeah, okay, that's exciting.
Yeah, because durability is obviously a huge part of housing. So
Yeah.
and it's also repairable.
Oh, is it? Okay.
Well, it has to be and renovatable by code, but we have both the ability to repair it using our technology and materials where it can be applied, but it can also be repaired using off-the-shelf materials like epoxies or sealants. So.
Oh, nice. Okay, nice. So then you mentioned that you have your shell and then you have your foam insulation. How are your utilities run? Are they interior to the wall, exterior? What does that look like?
Yeah, so on the units we're delivering currently, and we're using prefabricated bathroom units. So we're able to consolidate most of the MEP into a single location, which really streamlines the process and allows us to take advantage of domestic producers and who have already optimized what the development of those bathrooms. So for the current units, it runs to the drop ceiling, and we've got that wet wall. For the kit systems, on the initial iteration, we have a removable baseboard that allows us to run the electrical, and then for the switch level, we're using wireless switches. And that's kind of where the industry is going in general. But for the MEP, again, we're consolidating it into a centralized location to minimize the need to be running plumbing everywhere. And we're using mini splits, ductless mini splits for the heating and cooling to also, again, minimize the need for running ductwork and everything.
Yeah,
in the future,
people are going with the mini splits these days.
I mean, some of them are really great, especially if you can combine it with like a ground source heat pump or something. There's some really great energy efficiency and sustainability potential there. And where we're going with it, once we, again, additional certification, and then we're already working on this with UL, who's our partner, is the ability to print the channels directly into the panels and the shell itself, and use harnessed MEP systems that can be just plug and play. And so that's something, I mean, that technology is already utilized in terms of like harness systems already being utilized in ship building, and which is miles ahead of residential construction in terms of modularization and prefabrication. And so borrowing from that, we're taking that and then being able to use that in printed channels that fully leverage BIM. Because that's the other thing is with BIM, it's amazing technology, but the building technology hasn't quite caught up to really maximize it. But because we're keeping the design that stays in the digital file the entire time, literally up until the printer starts printing, it starts extruding it, we're really able to use that 3D model and really maximize the value of it.
Let's talk about that for a minute if we could, because I think most of our attendees or listeners are probably familiar with 3D printing and how it works and what a desktop 3D printer is. The printers that you're using to make these structures, I know they're much larger, but they operate on fundamentally the same principles, right? Of extruding material and... Sort of.
They do, it is an extrudable material, but it's actually a unique printing technology that we've created. Well, we call it PACE. So photo-activated component extrusion. And so what we've done is we've created a material that's an extrudable gel. Okay. But the curing process isn't time and temperature like you would normally have with your thermoplastics. Mm-hmm. What we've done is we're actually working with a thermoset composite. And to my knowledge, we're the first company that's figured out how to 3D print thermoset composites. So when the gel's extruded, we actually hit it with UV light. Mm-hmm. So it's so it's UV curable. And so that's what triggers the polymerization reaction. And that's what allows us to do things like unsupported spans and eaves and unique and curves and unique forms, because it hardens quickly enough that you get that ability to support its own weight, but not so quickly that you don't get full chemical cohesion between the layers. And so, it is a thermoset composite. So once that reaction's occurred, it's not going back to a gel. It is a phase change. You can't just melt it back down. Right. And then start over. So.
Yeah.
Very interesting.
And the printer itself is, according to UL, the largest light-based printing system in the world. So the print volume is 11 feet by 26 feet by 13 feet. So I think so a maximum footprint of 450 feet, maximum volume of something like 3,700 cubic feet. So we're actually limited more by over-road transport because we are doing this as prefabrication than we are by the actual print volume itself.
I was going to ask about that. So that seems like it would be a significant advantage of your custom material being 4 times lighter than concrete. Because if you were producing these in concrete and then trying to transport them on site, that would be a lot more weight to manage, right?
Correct. I mean, there are companies out there that have done that. Winsun in China is a great example. They're doing prefabricated 3D printed concrete. I believe they started on site, but then they moved in factory. And one of the cool things about prefabrication is that it makes it much easier to achieve the high level of quality control standards needed to meet the UL 3401 standard. And I'll explain that standard a little bit more in a second. But it also allows us to operate under California's Factory Built Housing Program, which is a program run by the state. And there's similar programs in all 50 states, Canada, and other countries. But essentially what it means is that rather than getting a building permit for the units from each individual authority having jurisdiction, so each municipality, we're actually able to get the building permit at the state level, working with a single code review official and single inspection agency that are approved by the state to act on their behalf. And that's because we're doing offsite construction, once the unit's there, you can't tear into the walls. You're not gonna be able to do the inspections on site that you would normally do in stick built. So those inspections are all done in our facility.
So then does that mean that once you expand throughout the other states and throughout the US, that you'll have certification within each state where you're established and the permitting is essentially already done for the clients that you're going to have, making it a lot easier to have these units on site?
Yeah, and the exact nature of the programs varies as to what can be certified at the state level versus the local level. Californians makes it really easy for the panel system to do the full, but some states allow you to only certify the panels as building components, and then you still need that local permit. So it does vary by state, but yes, that's essentially what we're going to be leveraging is that opportunity. And I think given the national movement towards a bigger embrace of offsite, and some of the new efforts like the Advanced Building Collaborative that the Department of Energy is launching to really accelerate the offsite construction, I think we'll probably begin seeing some changes in those regulatory structures to streamline things further.
Nice. Can we?
Because
Sorry, I was going to say, can we circle back to the UL certification?
Yes. Oh, thank you.
Means, and does that mean that these units are more resistant to fire, flooding, any of those things that have actually become, hurricanes, maybe depending on where they're located, that have become problems throughout the U.S.?
Yeah. Thank you for that. Yeah. So, we've been approaching the regulatory aspect of things from the very beginning, because we recognize that building codes are unfortunately written in blood. I mean, they exist because things went wrong and people got hurt or died. Yeah. And so it's incredibly important that when we're bringing new technology into this market, that we're doing so in a way that fully demonstrates the safety and the code compliance. And so to that end, we decided to work with UL, Underwriters Laboratories. Most people know them from consumer electronics, that little UL with a circle around it that you see all the time. But they're actually been around for over 100 years, and they started in building life safety. And so along with this over 100 years of building life safety and this global presence and a globally respected brand, they also have some of the world's leading experts in additive manufacturing. So they were uniquely situated to not only understand what we were doing, but to then understand it and then see what does it look like to show how this complies with the code. So that's why we chose them over, say, the International Code Council or IAPMO or some of the other evaluation services that are out there that do great work and are more commonly used in the building space these days. And from our work with them, because no one had ever evaluated technology like this for this use case, I mean, largely because this type of technology never existed before, they actually developed a new standard, UL 3401, for the use of 3D printing and construction, which kind of outlines a process for evaluating 3D printed construction for code compliance. In addition, that standard has now been added as an adoptable appendix to the 2021 International Residential Code. So that means that jurisdictions, everything from countries to small communities, can take that appendix, plug it into their building code, and have a codified way to evaluate 3D printing. And
even was that focused more on the methods, or did the scope of that certification and testing also include the material itself and the safety of that material?
Both.
Okay.
So because you've got a lot of different ways of doing 3D printed construction, it's more of an evaluation methodology. So looking at these are the different things you need to evaluate, like the mechanical properties, the fire performance, and a lot of it depends on the specific use case, because different use cases have different requirements in terms of what type of construction is allowed and not allowed, and those then under code have different requirements in terms of what kind of fire rating you need to have. And so at this point, we're the first and only company certified under that. And we're really proud to have been a part of bringing it into existence, as well as being approved under it. And additionally, we're also working with ASTM on their standards that they're developing around the application of 3D additive manufacturing and 3D printing to construction. Because again, we take the regulatory space really, really seriously and are really, really big fan. For us, it's really important that we're creating that framework, not just for us, but for the entire industry.
Exactly.
Because obviously, if something goes wrong with another company's 3D printed house, that doesn't just impact them, that impacts all of us who are really trying to leverage this technology to solve these problems.
Absolutely, absolutely. You know, one thing I've wondered about is when you're developing the designs for these homes, do you guys use like desktop 3D printers to model these?
We don't actually. Well, when we first, the very first version of our printer was a desktop printer. Okay. So some of the early designs, we utilize that, but no, we're using Revit, SolidWorks, standard design platforms that you would use in engineering and architecture already.
Sure.
And then we've developed
the full scale.
And then exactly, okay. Most of the work happened, and that's one of the cool things about what we're doing is that it is 100% digital fabrication.
Yeah.
It stays in the computer until we're ready to print it. Absolutely. And so that means we can do things like introduce design changes late stage with basically no additional cost. We can go from one design to another with just a push of a button, switching files. Yeah. It also opens up things like simulation. So we're working with MSC Software, which is part of the Hexagon Group, and we're developing simulation capabilities to simulate a build thousands of times before we ever get to the first prototype. And so what that means is we're able to identify quality control issues. We're able to identify design flaws that might not have been caught by the architects or the planners. We're able to identify production bottlenecks and mitigate them before we ever get to the point of actually building a unit. So that increases the number of first-time right builds. It reduces those costs of new product introduction by as much as 100 times, speeds that process by as much as 5 times, because if your first-time build is first-time right, you're golden. And then additionally, and then in production, because of the digital aspect, we're able to really eliminate 90% of the labor hours, but expand productivity by as much as 20 times. So again, creating more work at the end of the day. It also has 100% fully integrated quality control. And so it's what we're doing is really kind of helping the construction technology live into the promise of a lot of these software side of things, because over the last couple of years in construction, we've seen some amazing innovations in terms of what's available on the software side to improve that efficiency. And now what we're trying to do is really help prefab technology catch up to that to really maximize that value.
Interesting. So does that mean that customers have the opportunity to make changes to the floor plans that you already have existing without, I know that you said the wet rooms are basically standard. Sort of. Okay.
Like with our panel system, with the modules, it's more or less the Henry Ford model. You can have any color as long as it's black. We've got a couple colors. I think we've got like 3, but with the modules, it's a relatively limited customization that's available. Okay. With the panelized system, we do offer the ability of some customization for individual customers, not a ton, but maybe like move a window here or there. But for developers and builders, that's where it gets really exciting, because then we can create fully customized floor plans unique to their project using the panel system. And in the future, it's really about that ability to take third-party designs and 3D print them. And so now we love our designs, but that's our aesthetic. Our real goal at the end of the day is to be a tool for industry and is to be a design and market agnostic production as a service platform.
So in that case, right now, all of your units are single level. Do you have plans to go multi-story in the future?
We do, yeah. So we're already working on a system that is a apartment over garage. So that's kind of our first foray into it. And then with our new fiber reinforced version of the material, we're looking to really step into low-rise multifamily. Initially, that 3 to 5 story sweet spot where you have like maybe commercial, mixed use commercial on the first floor, and then 4 levels of residential. But eventually we could potentially go 10 stories. Who knows, maybe more, but 10 stories is kind of where we're looking, is at 3 to 10, because that's really your sweet spot for most residential development when it comes to multifamily.
Oh, that's really exciting.
Yeah, and we're hoping and we're not that far away from there. We're hoping to begin deploying, or at least be moving into the multifamily design stage in 2022. Because we already have the fiber reinforced material in development. It's just now it's a matter of moving it forward through the certification process.
How about off-grid? Is that something that has been done with these units yet, or is that something that's kind of in the works?
Not yet. I mean, it is theoretically possible. Obviously, it gets a little complicated. Then we offer solar. We've done so before, even before the California solar mandate came into effect. But then you get into the battery backups, and then you also, but where it gets more complex, frankly, is the sewage. And are you doing a composting toilet? Do you have to do a septic field? What's that look like? And so that's something that we could do. It's just we haven't had a strong request from customers yet, and so and obviously we're driven by customers. Like our goal at the end of the day is to serve our customers as best as we can.
Makes sense.
They have those incinerating ones as well.
They do. No, there's definitely some cool stuff out there, and if there was a strong interest by our clients, and we had someone who, like, that's definitely something we'd be willing to explore. It would honestly probably need to be more of an off-grid development to really justify the development costs. But
of course,
we're always open to exploring new ideas and really expanding things.
Excellent. Well, let's talk a little bit more about the process that people go through. If somebody wanted to take advantage and produce one of these structures, what is that like from initially contacting you all the way through to the final installation? What is that process like that people go through? Who handles what portions? I know you mentioned before that you guys have a pretty much an end-to-end service. What should the customer be expecting? What do they have to do throughout this process, and what do you guys take care of?
Yeah, so we offer full turnkey experience. So essentially, we take care of everything. So the customer comes to our website, or maybe goes to one of our pop-ups, demo units. We've got one in LA. I've got another one it was in Orange County. We're moving it down to San Diego. We obviously here at our facility in Oakland, because we are considered essential infrastructure, so we are legally allowed to continue operating, and have been, because obviously the housing need is so high. So meet with our sales staff, you, through our website, express interest. You place a deposit down, which is then used to run a compliance check to confirm that the ADU can be placed in the backyard where you want it, as well as to do a site visit, confirm all the things like what's going to be required in terms of utilities, what's going to be required in terms of foundation. And then we use that deposit to really establish a true price model. So because there's the unit price, and then there's a variable price depending on the nature of the site. And that's usually about a 30 to 40% markup. And the prices on our website are basically an estimate accounting for that 30 to 40%
Gotcha.
turnkey, additional cost of the turnkey. And then we handle everything. We work with the local authorities on getting all the permits for the foundation, utilities, the planning check. We coordinate with, we have a network of general contractors that we work with in different regions. So we coordinate the foundation, the utility work. We work with the crane delivery company, handle all that. We'll even call you if we need to figure out a place to crane, and we need to talk. We'll call your neighbors up. Well, we're really out there doing whatever we can to make life as easy as possible. And so we coordinate all of that. And with the modules, that installation happens. It can happen once the entitlement's in your hand, because obviously entitlements can be variable. We're looking at about a month, because the foundation, we're looking at a couple weeks for that to be poured and cured. And while that's happening, we're building the unit in the factory. So that's with the modules, they can be installed and delivered and installed and moved and ready in less than a week.
Wow.
Well, that's less than a week, as long as we can get all the trades on site at the same time, and
Sure.
and in the right order. So sometimes, like, some of it gets out of our control just based on the aspects on those external aspects. But we've got a great team network and a great group of GCs and trades that we work with. So we've gotten pretty good at optimizing that.
Nice. So let's talk about how these are being used right now. How are people making use of these? You mentioned ADUs. That's accessory dwelling unit. Is that what that is?
Sorry, I always forget that not everyone just knows what that means. So an ADU, yes, accessory dwelling unit. It's the technical term that the state of California has chosen to use. Some other terms are secondary unit, granny flat, in-law apartment. Basically just an apartment that you put in the backyard.
Yeah.
Or in some places the front yard or the side yard. And so the state, what's happened is the state of California has embraced these as a low-hanging fruit in our efforts as a state to help solve the affordability crisis. And so they've passed laws, a series of laws over the last few years that have really streamlined the permitting process and kind of limited what type of obstacles can be placed. So it's a ministerial review. So it doesn't go to the planning commission. Your neighbors don't get to complain. I mean, they can complain. It just, they can't stop the process as a result. It's a staff level approval. They've got 60 days to act on it. If they haven't acted on it after 60 days, it's deemed approved. So a lot of great things like elimination of floor area ratios, suspension of owner occupancy requirements, all sorts of things that to really incentivize individuals and families to build these. So the use cases range quite a bit. So we've got a number of people who are using them as the state was hoping, which is creating new rental properties. And that's a mix of both landlords who have a property and want to add additional unit there. We've actually delivered here in Oakland, over in East Oakland, delivered a unit for that use case. We have people who feel just need more space, and that's something that's become more and more true during the pandemic and shelter in place. People are realizing, as people's homes become their work, people are realizing they don't have as much space as they might have want. So we're seeing people who are using them just to have that extra space. Some people are using them as pool houses or guest rooms. Yeah. We're seeing a lot more multi-generational living. So as younger people maybe, and that's also something we've seen an uptick during COVID. Oh, yeah. Is that as a lot of young people maybe lost their jobs and had to, or just wanted to be back with family, moved home, but still want that privacy. So we're seeing that. And on the other end, we're seeing that same for seniors, where maybe you don't want to be in an elder care facility given what's happened in terms of the pandemic in those locations. Yeah. And but again, you still want your privacy. Right. Like we have one of our contracts we just signed. They've got like a 5-bedroom house. The kids and the grandkids are moving in, and so they want a apartment for themselves on the property, but they still get to be close to the family. Oh yeah. So it's really running the gamut. And the state's made it so you can't do, you're not supposed to do short-term rentals. So we're not really seeing tons of Airbnb, or at least not that I'm aware of. Okay. And that's kind of tied into something else I was wondering about. I don't know if you have this information, but of any of your customers that have purchased these units and kind of used them for rental properties or things like that, have they shared any information about their ROI or how long it took them to recoup their investment in doing that kind of a thing? I don't have that information off the top of my head. I know that our sales team does, though. Okay. I mean, it all comes down to the market. Yeah. And what you're going to be able to rent that unit for. That makes sense. But if you're looking at, say it's one of our 1-bedrooms or one of our 2-bedroom units, and we deliver it, and all in, you're looking, let's say 170 or 169 for the unit. So maybe, let's say it's a difficult site, it's 250. Yeah. So that and it qualifies for traditional financing because it is built to the state building code. It is considered real property. So from a financing perspective, it does qualify. So a lot of people use like a home equity line of credit or things like that. And then if you've got a 2-bedroom, depending on your market, if you're here in the East Bay and you're looking at a 700 square foot apartment, 2-bedroom, depending on the neighborhood, you're probably going for between like 2,000 to 4,000 per month. So so a couple of years. Yeah. It's pretty quick payback period. I mean, it's essentially the same as if you were just buying a property and then using that and using the rental to cover your mortgage and then with a little bit on top. Yeah, it makes sense though. I guess that especially given that you guys are in California, it's probably going to, rents are going to be higher out there, so it's probably going to be even quicker. Yeah, and then as we look to other states, again, that's why we're excited about the ability to have this distributed production because we don't want to be exporting California costs. Because California costs are insane.
So how do you see this technology kind of evolving and changing maybe the housing market? Because I know personally, I've been interested in alternative housing for many, many years. And when I first found out about 3D printing, I was like, oh, 3D printing and housing, those two should be a thing. I mean, we have such a need. So how do you see that shift happening?
Well, one of the things that we've seen, and one of the reasons we've kind of been looking at these kind of smaller size units, even with the single family homes we offer, is that there's been a loss of the starter home. So it used to be that you got a job, you got to start a family, and you were able to buy your first home, and you're like maybe in your 20s, and it was going to be maybe 1,200 to 1,800 square feet. You want to buy one of those today, you're looking at a 30 to 60-year-old house because they don't get built anymore. The overhead costs are too high and really don't actually make it just difficult for builders and developers to justify building something that small. So with 3D printing, we're able to bring those construction costs down and make that a viable option again. And there is demand for them. I mean, both from the younger generations, particularly millennials and Gen Z, who don't want a lot of space, just have space. They want the right size space. We're also seeing that among baby boomers who, as they're retiring, aging out, for them, it's about, again, why have a huge house that you're using a third of when you could just have a house that's a third the size and have just that right size. And so we're seeing the old seniors as well downsizing. So there's a growing demand for this right-sized units. And that's something that 3D printing, I think, really helps address in a way that's going to be affordable and still allow for profit margins for your builders and developers. Additionally, it opens up new opportunities of design. Because even though we can match a traditional aesthetic, make it look like any standard house, we also can do things, and this is why we have the curved wall, which it hints at. We can do freeform design. We can take a Frank Gehry house and do something and make something like that and make it affordable. So I'm really excited for what it means as it becomes more mainstream to unlock new ways of design, because so much of our form factors are based on the materials that we use. And so opening up new design possibilities, I think, is something that's really excited. And then the ability to deliver units at scale. And this is like right now here in California, like today, we need about 2.5 million units just to get to the per capita average for the rest of the United States. Not even necessarily close the housing crisis, but just to get on par with the rest of the country in terms of how much housing per person. At the rate we're building less than 100,000 units a year. We're going to build maybe 1 million units over the next 10 years. During that time, even with the pandemic, we're still going to need another 600,000 units. So after 10 years of building the way we build right now, we're still going to need 2 million units in California just to get to that average. So what that really speaks to is that we need a better way to build. We need a way that deal with the fact that we don't have enough labor. There's just not enough people. And even if you're going to be able to get those people, it can be really expensive. And so we need a technology that addresses that and really maximizes the value of that labor. And 3D printing is a great solution for that. It's also about the sustainability. I mean, we need to build more in a way that's, and frankly, I'm even hesitant to use sustainability. I'd much rather talk in terms of resiliency and regeneration. Because as you spoke to, we're seeing more impacts of climate change, fires, floods, more damaging hurricanes and tornadoes. And so we need materials and buildings that are robust, that are built to withstand those, which ours are. I mean, we're doing additional certification to fully demonstrate all that, but that's where we're going, is that ability to be fire resistant, wind resistant. I mean, I'm really excited for when we do start delivering to Florida, and I get to do a hurricane impact test. Basically, it means we get to shoot 2x4s at the wall at 100 miles an hour.
Well, that does sound like fun.
I know, right? And basically, our current internal test is one of the taking sledgehammers to it. We feel pretty confident it's going to do well, particularly the fiber reinforced version.
Sam, you tied into. We got a couple of questions coming in from attendees that are right along this topic. So let's cover those right now. One person is looking to follow up on something that Alina was talking about resistance to strong weather. And she says, having lived through a tornado in a mobile home, luckily tied down with airplane cables, I'm curious specifically about how these homes will hold up in weather systems like tornadoes. And you mentioned foundations. Do any of them have full basements as foundations?
That person lives in the Midwest. As a Michigander, I know because we don't have basements in California. It's something I learned when I moved out here. That doesn't mean we couldn't. It just means we haven't. We don't. Most of these have been just a slab on grade, but we have designed them to be basically universal. So pier systems, skirt systems really depends what's best for the location.
Okay.
The units themselves are designed to be variable. So yeah, you can totally do it. Like no reason you couldn't do a basement. We haven't because they just don't really exist in California.
Sure. Okay. So setting aside the basement, let's say a tornado rolls.
Yeah. So I just wanted to put that, and then, but the tornado. So yeah. So we have to. While we haven't we don't really have tornadoes in California. We do have pretty much everything else. So we've designed them to be incredibly, they're earthquake resistant. They're designed to withstand earthquakes anywhere except for like one spot. I think it's the San Pablo forest, maybe. I don't know, whatever. It's like the worst spot in California for an earthquake hits. There's a reason no one lives there. But it's also fire resistant. We do get some pretty bad winds, and so it is designed to take high wind loads as well. It is also not a mobile home. These are built to the state building code, not the housing and urban development code. So they're not on a steel chassis that has wheels. They're a permanent foundation that's bolted or welded to the foundation. So they're permanently attached. So that adds to their ability to withstand those high winds. Also, even though it's 3D printed, it's not a plastic. So we're not talking about some flimsy light material that's going to blow away.
Yeah.
It does have, it is solid. It has weight to it. So it's again, don't quote me on it, but it should do pretty well. Although in a Category 5 tornado, I'm not sure anything like short of a in-ground bunker, you're going to have potential for trouble. But no, we've designed them to be very hardy and very robust, given the realities of climate change and what that means. But it has been primarily focused on what we have here in California, but with an eye towards things like Florida, the Midwest, places where you do have tornadoes, hurricanes. And we do have snow here in California. We've got some of the hottest areas in the world, some of the snowiest areas in the world. So we've got a wide variety of climatic realities that we've already had to begin to address.
Sure. And you might have just answered the next question from another attendee, which is, do you offer hurricane-proof windows for areas that are impacted by hurricanes every year?
If we're delivering to Florida and it's a code requires hurricane impact windows, they will have hurricane impact windows. And having lived in Florida for a bit and had to evacuate during Irma, those things are important.
And the follow-up to that question was, would the unit be flood-proof then when the waters rise?
So the material is what does one mean by flood-proof? Is it a watertight box? I mean, it's pretty airtight. It is pretty well sealed, but you still have windows. You still have, and water pretty good at getting places. Yeah. That said, and also having been in New Orleans with the Red Cross post-Katrina, having seen what houses look like after they've had 14 feet of water for 2 weeks, and never wanting anyone to have to experience that if they don't have to. It is naturally antimicrobial, so you're not going to deal with the fact you don't have to worry about it turning black from mold. And having gone in and done demo on some houses, that's a real issue. It's also naturally hydrophobic, so the water itself shouldn't really damage it. Nice. So it's designed to hold up pretty well in a flood. But yeah, no, having seen the aftermath of Katrina and seeing what it did to some of those houses, that's something that we feel pretty good about our material being able to. I mean, again, not being flood proof. Like again, water probably is going to get inside. That's just windows, and part of that's we don't make the windows. There's certain things that we don't have control over, but we do get high quality products. But it is designed to survive the impacts of a flood.
Nice.
So is that what we're talking about now? Is that the reason that you all chose to print in-house as opposed to on-site? Because a lot of companies out there that are 3D printing here in the States or globally are doing it on-site, where they bring the machine and then they print with whatever material, concrete or whatever the material is.
Yeah. So there's a few reasons for that. Frankly, as we spoke to before about the weight of concrete makes it difficult for prefab, but even more than that, 3D printed concrete, it's not, you're really 3D printing formwork. You're not like when people say 3D print, oh, I got 3D printed concrete house. It's like, sort of. You got a 3D printed wall of formwork that then they manually installed rebar into and then manually poured aggregate into. So there still is these traditional, and so that they're getting that, like there are some really interesting work being done in things like printable basalt reinforcements. And so there are movements towards creating truly 3D printed concrete. And it's technically not concrete because it's mortar. It's small. It gets down. But that said, I think I'm really excited for what's happening in that space. I think anything moving 3D printing forward in the construction space is good. But that type of technology doesn't lend itself well to prefab. It also means you're not printing the roof. You're only printing the floors and walls. You're limited in what you can do designs or ranks. So we chose to do it prefab for a number of reasons. One, better quality control. We don't have to worry about weather or other environmental factors in the print. We also don't have to worry about setting up and tearing down, recalibrating all the time in that regard. We don't have to worry about turning off the printer at 6 p.m. because that's when construction's banned overnight in most residential areas, or 9 p.m. or whatever it may be. So we can print 24/7. It also allows us to achieve the quality control standards for 34.1 and for building code much more easily, as well as opening up that ability to have multiple stages. 3D printing is just the first step. Then we also have the robotic post-processing that allows the milling of the surfaces, the pouring of the foam, the opening up of these additional opportunities, both for quality control and the manufacturing process. And lastly, it allows us to do things at scale under programs like the California's Housing Community Development's Factory Built Housing Program, where it makes it that much easier to permit them at the state level rather than having to convince every single local building official that it meets code.
Yeah.
So those are some of the big advantages. I mean, because when we started, we actually were looking at what would it look like to do on site. But as we kind of pretty quickly as we got into it, we realized the opportunity is there for prefab. And part of that's also, if you look at the industry, prefab is the future. We're already seeing traditional construction moving in that direction because you can achieve greater efficiencies, you can achieve greater quality control. You can really do more in a prefab space than you can on site. You have more potential for customization on site, but that's something that that 3D printing actually begins to bridge. So.
Interesting.
Do you see more work being done in the automation of other aspects of the production in terms of like laying in the electric and plumbing and stuff like that? Is there going to come a time where that's actually laid in by machines as part of the build process?
Essentially, I mean, our target really is only about 80% automation, and part of that's right because you still need the human touch.
Yeah.
In the future, there may get to a point where that automation level, we can get closer to 100% automation level, but that means that we as a society there's bigger societal questions around what do we do with automation and what that means for workers, what that means for productivity. So there's a whole bigger conversation there that involves universal basic income and other aspects that would have to be, that I think would be involved in getting there. But yeah, I think in the future, there may be definitely opportunities for utilizing additional automation beyond the 80%. But for right now, we're really just targeting 80%. And it's both because we do believe that it's still important to have that role. And there are parts of the build that just make sense for humans to do, particularly where technology is now. Yeah. But additionally, having seen what happened to Tesla when they tried to go for a full 100% automation or 99% automation on the Model 3 line, it almost put them out of business. So that's also lessons learned from having looked across the landscape and kind of seen those companies that inspire us and have done amazing things. Because in a lot of ways we see we actually even had a customer say that we call us the Tesla of housing. And there are a lot of parallels. I mean, our first version of these units is a hybrid, similar to how the first Roadster was a Lotus was an electric Lotus effectively. But it was combining new technology with something that already existed, similar to how we've got the 3D print curve with the steel frame box, and then moving into that next generation like our panel system's kind of like our Model S, as it were. And really understanding what it looks like to begin to use cutting edge technology to address major drivers of climate change. I mean, because Tesla, they're both an energy company and a car company under the brand technology, but they're really going after the large portion of emissions that are related to transportation energy use. You've got companies like Just and Impossible Foods and others that are going after that big portion of climate change that's related to agriculture.
Right.
We see what we're doing is similarly trying to take new technology and address the construction and building, which is combined 39% of global emissions.
Yeah, oh, that's excellent.
Are you thinking of using this technology to kind of start addressing the homeless crisis, not just in California, but throughout the US, by building smaller units where they can kind of be, I know that there have been some tiny home, kind of homeless communities that have popped up in certain areas. Is that something that you guys have talked about with certain municipalities in order to help them address the crisis that's happening?
Yeah, there's definitely a lot of interest in that. And it is in our roadmap, and it is definitely a problem that we are looking forward to being a part of the solution for. Initially, it's not where we've been focusing. And there's a couple reasons for that. One is that there's a huge need in the missing middle. So there's people who don't qualify for subsidized housing, who don't qualify, and that's like your teachers, your firefighters, the people who serve communities, but are more and more not able to live in those communities. So that's really our initial focus, is focusing on that. And that's also, we didn't want to be in a position where we start with supportive housing and low-income housing and get pigeonholed, because our goal has always been to be completely market agnostic and really be able to serve the entire industry, whether you're building luxury homes or whether you're building homes for supportive housing for the homeless. But we also believe that even no matter what, it should be high quality. It should be a house and something that you can be proud of. That there should be dignity in that housing, no matter what your situation might be. So yeah, we're very excited for that, and that's particularly when we get into multifamily, we see a really huge opportunity here in the Bay. Depending where I think the average across the Bay right now is $750,000 per unit of affordable housing.
Wow, that's
very
expensive.
It's insane. And it's one of the reasons we have such a lack of affordable housing. And so that's one of the things we're really excited about is the opportunity. And that's where you start getting into mixing with low-rise multifamily, where you maybe have mixed use as well as mixed income. And there's also opportunities when you begin doing that to have zero setbacks, really maximize the density bonuses, really maximize how many units you can get in there. And so there's definitely some huge opportunities that we're really excited about. But we've also had conversations in the near term about what's it look like to develop little bedroom units for transition centers that are popping up more and more in the Bay Area and elsewhere, where you've got kind of complexes where everyone's got their own bedroom, but then you have maybe communal bathrooms and kitchens. So having little boxes, and so that's something that we've had an interest in. There were some conversations about. So it was definitely a use case and a community that we're looking forward to serving, but it's not one that we've deployed anything for yet.
So that's kind of like a co-housing community situation.
Kind of. I mean, it's one of the situations where it's about getting people in housing, providing on-site services, because obviously there's a lot of people have done some great work on the housing first model, where you're getting people basically addressing the Maslow's hierarchy of needs, and of which housing is a huge part.
Definitely. So what does your timeline look like? I know you guys are in California now, because this is very exciting, not just for California, but for the country itself. What's your timeline look like for expansion throughout the Pacific Northwest and then further into?
Yeah, I mean, so as I mentioned briefly, we have some interest already from developers across the country. So we're definitely looking to move forward with some of those in the next couple of years. The hope is by the end of next year, because this next year is about because right now we've got a single printer, we're able to generate about 200 units a year. The goal is to get to 6 printers and be able to generate 1,000 units a year, which is like 1.2 million square feet of production out of a 50,000 square foot facility. So that's what next year is about scaling and getting that right. And once we've done that, then it's about how do we replicate that. And that's where conversations around joint venture factories and working with developers and some of these partners and developers that we have interest from, and looking to begin deploying that. And the great thing is that we can, as I mentioned, use existing warehouse space. We can spin a factory up in pretty fast, 3 to 6 months. And we can do so for less than $10 million. So it's pretty cost effective as well.
That's very exciting news.
That is.
I can't wait to see where you guys end up.
Me neither. If 13-year-old me is really excited about what I do. I mean, I just to lay bare just how much of a nerd I actually am. I fell in love with 3D printing when I realized that Star Trek replicators were just atomic or molecular level 3D printing with energy modulation.
That's right.
And then I was hooked. My capstone to my team in grad school, our capstone project was taking clean, uncontaminated, virgin plastic that normally would go to landfill from hospitals and converting it into 3D printer filament. So it's been something that I've had a passion for, but not necessarily something that I ever saw myself working in this capacity. So it's been an incredible journey, and was like when I first connected with my co-founder, with my co-founders, our CEO talked about his idea. I was like, done. Like where do I sign up? And so it's been really great then bringing in like policy side and really helping navigate what does that mean to bring that into reality and kind of navigating that regulatory process, figuring out ways that we can streamline the compliance process and approval process and everything. And then obviously maximizing the sustainability, because that's a core value. I mean, the fact that we have someone with a chief sustainability officer title speaks to how seriously we take that commitment.
Yeah. Yeah, it does. It's very exciting. And it's great that you are doing it this way. Like you said, you're not just, the work that you're doing in terms of the certifications and establishing standards, it's not just going to benefit your company, but others getting into this industry. So it's really very,
because we believe that it's a big enough problem that there's room for a lot of solutions. Yeah. And there's room for a lot of different 3D printed solutions too. And so we just want to make sure that the regulatory structures in place to make sure that those solutions are being done safely and done in a way that really makes sure that people are getting what they expect in terms of quality, and also ensuring that we don't have something that's going to set the industry back by decades, because the problem's so acute that we don't have time for that.
Yeah, and that's the exciting thing that's happening with a lot of prefab these days, is that it's not the prefab of 30 years ago. Yeah. The quality has really changed. Not obviously you guys are doing something completely different, but others that are doing still stick built prefab, that quality has improved as well.
Yeah. And a lot of people still think of, when they think prefab, they think of mobile homes. Yeah. And the reality is a lot of it, frankly, it's not even because that's where it gets complicated. Manufactured homes versus modular versus so, because manufactured homes are technically built to the HUD code with the steel chassis, but yeah, the quality even in those has improved. They're still not, they don't necessarily appreciate, they're still not necessarily treated the same as traditional housing by like the financing and other aspects. But yeah, you're completely right. The quality of those has gotten a lot better, and they actually get a bad rap based on the historical quality.
Yeah. Well, it's nice to see what you guys are doing. I'm so glad that you joined us today, because it's something that I've been following for such a long time. So it's been super exciting.
As you can see, I love talking. I feel so grateful to get to do what I do, and really, really appreciate you guys giving me the opportunity to share with your audience and for all the great questions.
Absolutely.
Really, can't believe it's already been an hour. You guys made this a really easy conversation.
It's funny how that works, isn't it? We still have other questions. We wish we had time, so we'll have to maybe.
So episode 2.
I love the idea of having a 3D printed a 3D Universe office at some point in our future. That would be very cool.
Well, let us know. We'll talk. And if your audience wants to find out more, they can go to mightybuildings.com. We also are on YouTube, youtube.com/mightybuildings, Instagram, Facebook. To be fair, do be warned, once you type our name in or you mention us out loud, you'll probably get ads.
You're going to find a lot. Okay, well, that's good. That's good. And you can always check our blog at 3duniverse.org. We're going to write up a summary as a follow-up to this session, and you can always find upcoming episodes for 3D Universe Untethered there. So just go to 3duniverse.org, check the graphic in the upper left for 3D Universe Untethered, and click that to go to our schedule of upcoming sessions. That's also where you'll be able to find recordings for past sessions like this one. So again, Sam, thanks so much for joining us today. It's been a great discussion. I learned a lot. Thank you.
Well, thank you, Jeremy. Thank you, Alina. Thank you, Jen. Really, really thank you to the entire 3D Universe team. Yeah, this is a lot of fun, and I look forward to doing it again.
Yeah, sounds great. Thank you, Sam. Have a good evening.
You as well.
Thanks everyone for attending. We'll see you next time. Bye-bye.